I had this idea for a heater that uses a linear actuator to push a cast iron block back and forth. Because of friction, the block and the other cast iron surface would heat up. I'm going to investigate if this is a viable product. The specific heat of cast iron is 460 joules per kilogram Kelvin. Generally, you only turn a heater on a cool day, and so our initial temperature is going to be a chilly 15 degrees Celsius. The total mass of my design is 30 kilograms, while the distance the block travels back and forth is 1 meter. This linear actuator applies a constant force of 1000 newtons and switches direction instantaneously. The block travels at a velocity of 20 centimeters a second, which is the same as 12 meters per minute. So if I run the heater for 1 minute, the distance the block will travel is 12 meters. Because both blocks are cast iron, the effective distance that friction is applied is 1/2 of the total distance. The change in thermal energy is equal to the force of the linear actuator dotted with the total distance, plus the force of the friction dotted with the effective distance. Because this is the only interaction, the force of the linear actuator is equal to the force of friction, which is all 1000 newtons. Filling what we know in, we find that the change in the thermal energy is equal to 18,000 joules. 18,000 joules is hard to visualize. How effective is my heater at actually heating? I know that the change in thermal energy is also equal to the mass of the object times the specific heat times the change in temperature, which is actually the final temperature minus the initial temperature. Look, we know all of these values too, except for the final temperature, which we found to be 16 degrees Celsius. If the heater warmed up by 1 degree Celsius in 1 minute, how much would it heat up in 1 hour? After an hour, the two blocks have been sliding across each other for 720 meters. The effective distance is half of that, 360 meters. Once again, the force of the linear actuator is the same as the force of friction, which is 1000 newtons. Our equation for the thermal energy is also the same. Plugging this all in, we find that the change in thermal energy is 1,080,000 joules. Now I ask, how hot would this heater get after an hour? Using the same equation as before, I find that the temperature of the heater is now 93 degrees Celsius. This is, of course, the surface temperature of the heater. I need to compare it to other heaters to see if it's efficient at heating a space.